Hi everybody, my name is Natalie Villafranca and today I'm going to be talking about magnetic fields and how turtles find a way home. So to start out, I'm going to be introducing three topics: electric fields, magnetic fields, and magnetoreception. I'm not actually going to be talking about electric fields in the presentation. I just wanted to introduce them to contrast the difference between electric and magnetic fields. So electric fields are fields that surround an electric charge which either repel or attract other charges. In contrast, magnetic fields are used to describe magnetic forces surrounding something magnetic. What I'm going to be talking about today is a phenomena called magnetoreception in turtles, which is where turtles are able to have a sense of direction using this Earth's magnetic fields. So magnetic fields are pretty similar to electric fields, except they're magnets. This photo represents field lines. These lines don't actually ever stop or start. They always end up in closed loops. The direction of the magnetic field is shown by the arrows on the lines. The right side of the magnet represents the north, while the left represents the south. Pretty similarly, this is how the Earth's magnetic fields work. I'm sure everyone is familiar with the North Pole and the South Pole. So these are the Earth's magnetic geographic poles. When you think of like the North Pole, Santa Claus, you're thinking of the geographic poles. But the magnetic poles are actually pretty similar. As you can see in this photo, the magnetic poles are pretty similar to the geographic poles. So these poles are due to the Earth's core magnetic poles, which are driven by electrons. These magnetic fields are huge. They literally expand into space, which is actually shown here in this photo. So while electromagnetic fields in of themselves are really cool, there are actually organisms that use magnetic fields to find their homes. So, for example, turtles actually use magnetoreception to guide them to their nesting spots. I learned about this last year in my marine biology class, which I thought was really cool because a lot of marine organisms have a lot of different ways of sensing things, and turtles can move around using magnetic fields. So turtles could leave their homes, go out into the ocean, do their thing, and then go back to the exact same place where they came from with no other GPS other than magnetoreception, meaning they use the Earth's magnetic fields to guide them back home. I don't really think that this phenomena has been giving a reason yet, like biologically, like what's going on in the organism that's causing this. The first study that actually confirmed that magnetoreception happens in turtles was actually published in 2008. But there is still a lot of work to be done in this field, as in most things in marine biology. So what the study did is that they got three different groups of turtles and then they set them out into the ocean. The first group had a magnet attachment added to their head so they like put these like attachments on their shell actually, which they attached before the study, and then they left them on when they released them. So they were swimming around with those magnets on them. And then the second group, they had the magnet attached during transportation out to the water where they were going to drop them off, but then they removed the magnet once they actually did drop them off. The third group was a control group and had no magnet. So what the study found was that all three groups were able to find their way back to the island, but the control group made their way in a much less complicated way than the others. So the pink on the left was group one, which is the one with the magnet on their head. So that was obviously interfering with did it stop recording? Oh no, I think it's still going. It was interfering with their magnetoreception because they had these magnets on their head and they were like, oh, what's going on, right? So then the black in that photo is the control group, so they made it back home a lot faster and a lot more efficiently, while the ones on the right, the red lines you see, is the group two, which is where they attached the magnets before they went out, but then removed them once they actually set them out. And then the black again is the control. So these indicate that turtles, in fact, do use their magnetic fields to find their way home, and they can still find their way back home using other mechanisms, but magnetoreception is the most efficient one, which we can see that when they lose that ability to have efficient magnetoreception, they take forever to get back home. Another study found that these cues actually influence the population dynamics of a community. So it will predict what a specific sea turtle population looks like. Additionally, they found that beaches with similar magnetic fields will be home to turtles with similar genes, while beaches with different magnetic fields will be home to turtles with different genes. It's pretty cool to think about how physics even has an impact on genetics and population dynamics. Usually when you think about these topics, you don't really think of physics. That's not really like the first thing that comes into your mind. So I thought it was pretty interesting that magnetic fields are so in charge of these things. So in conclusion, magnetic fields are very cool and allow a whole species of animals to have a sense of direction, which also directs their population dynamics and that specific community's genes. And here my works cited. Thanks for watching.